Hello everyone and welcome to our channel Mathematics Schoolio. Here in this video you will find an awesome question from calculus that will help you realize what's the role of observation in maths, and further it is also going to help you learn that sometimes we have to think out of the box and blindly using the orthodox method is not always a good idea. So without any delay, let's start the question. The question goes like this. Let f of x is equals to cos of x cube minus 4x square plus 5x minus 2. And if we let fk denote the kth derivative, fk denote the kth derivative of f, then compute f10 1. Now for the sake of this problem, they have given us the value of 10 factorial. We will be using it for writing down the final answer. Now what we are going to do for solving the question. So let's start solving the question. See, what I'm going to do here is, first of all, I'm going to look at the function f of x. Ultimately, the question just says that you have to find the 10th derivative of the function f. Function f is a cosine function, but in terms of x cube minus 4x square plus 5x minus 2. Had it been cos x, I would not have minded differentiating it 10 times and getting my answer directly. But obviously, when you look at f of x given in the question, f dash x, yes, we can manage. F double dash of x, yes, we can find out. But as you proceed with the successive differentiation, you will find that the function is becoming more bulkier. So going till the 10th derivative will become very difficult if we proceed directly. So what we are going to do, now we are going to observe it more carefully. Observe specifically this expression. Why? Because I have the problem only with this. I don't have any problem with cos. The only issue in this question is in front of cos, a cubic expression is written. And we have to find out the 10th derivative at x equals to 1. So when you check x equals to 1, when you keep it in x cube minus 4x square plus 5x minus 2, you will find that it is becoming 0. When x is 1, this expression is becoming 0. What I'm going to do is, I'll try to rewrite this cubic in terms of x minus 1. Now, either you can start by factorizing it because 1 is the root of this cubic. This we have just verified here. Or you can also proceed like this. Okay, let's write x cube minus 4x square. See, I have written minus 4x square. Instead of that, I have written minus 3x square. Actually, I'm just trying to create x minus 1 ka whole cube. Leftover terms, yes, I'll have to adjust them. So they will be adjusted like this. Now you can see that the cubic, which was given in the question, can also be written purely in terms of x minus 1. I'm going to rewrite the question by using a substitution. X minus 1 is equals to t. So let's proceed and rewrite the function f of x. So f of x, they have given cos of x cube. So I'm writing it as x minus 1 ka cube minus x minus 1 ka whole square. So this is the expression that we have, and using the substitution, now I'll have, instead of x, I will be replacing it with t plus 1. So let's say that it is a new function, which is g of t. On the right hand side, you will be getting cos of t cube minus t square. What we have to calculate in the question is f 10th derivative of f at 1. I would say that this is same as finding the 10th derivative of g at 0. So when you keep t 0, automatically x is going to become 1. That's why calculating the 10th derivative of f at x equals to 1 will be same as calculating 10th derivative of g at t equals to 0. But now the question is, again, I'm not going to differentiate it directly. I will not be differentiating it directly. Instead, what I'm going to do is, I'll use the series expansion of cos. So let's rewrite g of t. G of t can be written as 1 minus t cube minus t square. T cube minus t square whole square divided by 2 factorial. I'm making use of the cosine series, writing down the next term, which is t cube minus t square whole power 4 upon 4 factorial. The next term is going to be t cube minus t square whole power 6 upon 6 factorial. and so on till infinity. So here is the expansion of g of t, and what I need to calculate is 10th derivative of g at t equals to 0. So let us proceed. What I'm going to say is, I will write that g, or the 10th derivative of g at t equals to 0 is going to be equals to 10 factorial times the coefficient of 10 factorial times the coefficient of t raised to the power 10 on the right hand side of expansion. On the right hand side of expansion. That means in this expansion, you just need to find out the coefficient of t power 10 and multiply it with 10 factorial. But how can I say that this is going to be my answer? So let's see what actually I am doing here. When you look at the expansion on the right hand side, you will find that right hand side contains different powers of t. When you differentiate g 10 times, all the terms having degree more than 10 will become 0 on keeping t equals to 0. And 10th derivative of g when t is 0. So all the terms which are having the degree less than 10 on the left hand side, on the right hand side, sorry, it is going to become 0 automatically. So we can say that only the term containing t power 10 is going to be left out. So two reasons are there. One is all the terms having degree less than 10 will become 0 because of differentiation. And all the terms having degree greater than 10 will become 0 because we are going to ultimately put the value of t as 0. So that is why we are interested only in identifying the coefficient of t power 10. Now my next thing is how to get the term or the coefficient of t power 10. So let us look at the terms from here till infinity. You can see that all these terms will have the least degree of t more than 10. As you can see that in this term, the least degree of t that we are going to get is t power 12. After that, we will be getting the term, or all the terms of t will have a degree more than 10. So all these terms are not going to contribute in the answer. Let us look at the first term and the second term here in the expansion. In the first and the second term, you can see that none of the term is reaching up to t power 10. Or you can say that all the terms here are having a degree less than 10. So again, this term is also not of any use for us. What about this leftover term? When you look at this leftover term, you can see that yes, here t power 10 can be created. Because the least degree you will be getting t power 8, the highest degree that we are getting is t power 12. So let us find out what is the coefficient of t power 10 in this expansion with the help of binomial expansion. So I will be writing 10 factorial. Obviously, I hope you understood why 10 factorial will come, because I'm just going to explain it over here a little. Suppose t power 10 is there, whatever the coefficient is, I'm just writing the coefficient as capital A. When you differentiate it, you will get 10a t power 9. Differentiate it once more. You will get 10 into 9 into a into t power 8. Keep differentiating it like this. Ultimately, it will become 10 factorial multiplied by a, right? So a t power 10. When you differentiate it 10 time, 1 time, 2 time, 10th time, answer will be 10 factorial a. This is what I'm using in the question. So 10 factorial is fine. Now I'm writing the coefficient of t power 10 on the right hand side. Assuming or applying the binomial theorem expansion, just writing the general term for CR. What you need is t cube raised to the power r. Then you will have to write minus t square raised to the power 4 minus r divided by 4 factorial. What I need here is only the coefficient. I'll just be calculating here the coefficient of t power 10. So proceeding further, I need to find out what exactly is r. I'm interested more in the value of r. So for that, what I'm going to do is, again in the rough, we will do the calculation part. So for that, see here the degree of t that we are getting is 3r plus 8 minus 2r, and I want this degree to be equals to 10. When you solve this equation, you will get the value of r as 2. So while writing down the coefficient, all the t terms you need not to write, only the coefficient are to be written, and t power 10 coefficient will come when you keep r is equals to 2. So keeping r is equals to 2 gives me only 4c2. The negative sign will get absorbed because even degree you will be getting, divided by 4 factorial. Now you can see that 10 factorial value already they have provided us, which is 3628800. multiplied by 4 factorial. So you can see 4 factorial. We know the value of 4 factorial, or you can write it like this as well, divided by 4 factorial. So basically, we just have to divide the numerator with 4 to get the answer, which will be 907200. So this is the answer. This is how we should solve this question. So that's all. So let's end the video here. See you in the next video. Meanwhile, please like the video and share the video. Subscribe the channel for enjoying these new and quality questions. Thank you all. Bye-bye for now.